for 4. It says that acid which its molar mass is 126.07 grams per mole, is often used as a primary standard for the standardization of a sodium hydroxide solution. If 0.147 grams of oxalic acid dihydrate is neutralized by 23.64 mils of a sodium hydroxide solution, what is the molar concentration of the sodium hydroxide solution? Oxalic acid is a diprotic acid, and what is the balanced equation? Okay, so let's write out our formula. We would have our oxalic acid and it's added with sodium hydroxide. And since this is a neutralization, we would form water plus a salt. So in this case, it would be Na2C2O4. Okay, so now if we balance this equation, you'll see that we have 2 sodiums on our product side and only 1 on our reactant side, so we put a coefficient of 2 in front of sodium hydroxide. And now we have 4 hydrogens on our reactant side and only 2 on our product side. We're just going to try to fit another 2 in front of the water. Okay, so now everything should be balanced. And let's write down everything that we know for this problem. We know the molar mass of the oxalic acid is 0.147 grams. And we know that its molar mass, this is its mass. And its molar mass is the 126.07 grams per mole. And we know the volume of the sodium hydroxide solution. I'll use a different color. So this is oxalic acid. And for sodium hydroxide, we know the volume that was added to neutralize was 23.64 milliliters, which we can convert to liters as well. 0.02364 liters. And we want to find out the concentration of sodium hydroxide. And its values are in moles per liter. Okay, so this is a multi-step question. And step 1 is to find the number of moles of oxalic acid. So we can do that by dividing the mass by our molar mass. So the mass of oxalic acid was 0.147 grams. Its molar mass was 126.07 grams per mole. And if we divided the two, we get around 1.17 times 10 to the negative 3 moles. Okay, so step 2. Using mole ratios, we can find the number of moles that reacted for sodium hydroxide. Okay, so we know that 1.17, I'll write up here, 1.17 moles of oxalic acid reacted to neutralize the reaction, and we know that oxalic acid and sodium hydroxide react at a 1:2 ratio. So since we're trying to find the number of moles of sodium hydroxide for the mole ratios, sodium hydroxide will be on top. So 2 moles sodium hydroxide, and oxalic acid, which is the moles or the units we're trying to get rid of, will be at the bottom. So if we multiply this by 2, we get around 2.34 times 10 to the negative 3 moles of sodium hydroxide. And finally, we can calculate concentration. So recall that concentration is equal to number of moles over volume. So we know that the number of moles that reacted was 2.34 times 10 to the negative 3. And the volume of solution that was added to neutralize was the 0.02364 liters, which gives us our final answer, which is around 0.098 moles per liter. Okay, so now let's see what the junior tutor said. They wrote out the balanced equation, and they just found the mass of sodium hydroxide instead. This is another way of doing it. And then converted that to moles. So 40. Yeah, so it looks like they just multiplied. I'm not really sure how they did this. But I'm just going to say is incorrect. We need to take into account molar ratios of oxalic acid and sodium hydroxide to solve this question.